Okay, so here's a video for GeoGebra and how to use GeoGebra on a one probability hypothesis test. So here's an example, a pretty good example, I think. I like it. So about recidivism rate. So the rate at which convicted felons essentially go back into the system. So the recidivism rate for a convicted sex offender is 10%. A warden suspects that this percent is lower if the sex offender is also a drug addict. So we got a question, right, which goes into our hypotheses. If of the 330 convicted sex offenders who were also drug addicts, 26 of them became repeated offenders. What can be concluded at the alpha of 0.05 level of significance? So 5% level of significance, what can we conclude from this, right? So we have to write the null and alternative hypothesis. I have them written here. That's not the point of this video. The point of this video is to get to GeoGebra. So once we have the null and alternative hypothesis, the next step is just to determine the p-value. And so that is the point of this video. So let's go to GeoGebra, right, and see GeoGebra. So I will have a link for you for this, right, and it'll bring you up into this page for the classic pound probability section of GeoGebra. So we'll have links provided for you. But so this isn't the page I really want, technically. I really want the statistics tab. And then I'm going to come to the particular test I want to do, which is a z-test of a proportion. A singular proportion. So there we go. And then we just have to fill in the blanks here. So the null hypothesis. The null hypothesis is P equals what? Oh, P equals 10%. That 10% recidivism rate for sex offenders. So is 10% or 0.1 as well. So, so the alternative hypothesis, all we need is that symbol that we used, right? But notice, right, the warden suspects that this percent is lower, and lower refers to a less than symbol of this. So there we go. We got lower now. And so now we want the sample of successes, but successes is kind of a weird term for this because our success is actually that they become a repeat offender. In this case, that they go back into prison. So, all right, so and that's the 10% case, right? That's the population proportion is 10%. We want to show that ours is lower. The warden wants to show that ours is lower. So how many sex offenders did we have out of the total that became repeat offenders is 26. So sample of successes, they give it to us directly here, is 26 out of the total of the sample, which is 330. So we get both the sample of successes, don't have to do any work here. Some cases we might to find it, and then also the sample size, which is 330. Big sample size makes it hard to get differences between our population proportion versus our sample proportion, which is actually 26 over 330. 26 over 330. Just because I like looking at this, 26 divided by 330 equals about 7.8% is what that's saying. So 7.9% technically, if we round correctly. So lower, yes, but is it low enough to cause a statistical significance? And that's what we're testing out here. So with this information plugged in, you might have noticed that all this information below came up with our test. So our test is telling us that the p-value itself, so just to kind of go over the results here and what you have. So you have your number of successes, which is 26, your n. These are just copied from above. Then you have your z, which is your test statistic. So the test statistic is given first. Is equal to negative 1.2845, which can be used as well, right? We can use that tool that our Canvas site has given us in order to actually determine the p-value. But GeoGebra is easier than that. They give us directly, just by inputting this information, the p-value on the next line. So p-value is equal to 0.0995. So I will finish this here, but right, the rest of the problem will answer the question of what this warden has. So there we go.